For the first problem, we have 10 to the second times 10 to the fifth. We'll be using our first rule, x to the m times x to the n equals x to the power of m plus n. In other words, when we have the same base and we're multiplying, we keep that same base, 10, and add the two exponents, 2 plus 5. So my final answer here would be 10 to the 7th. In problem 2, we have b to the 4th being taken to the 7th power. In this case, we use our second rule, x to the m to the n equals x to the m times n. In other words, if we have some base to an exponent, in parentheses, being taken to a different power, where you can see, in this case, we had two different bases each to a power. This time we have one base to a power to an additional power. Power to a power, we multiply, so this becomes the same base b, but now to the power of 4 times 7. Since 4 times 7 is 28, it becomes b to the power of 28. Problem 3 uses my exponent rule 3 that anything to the 0th power just equals 1. So this says 7 to the 5th. You could see it as power to a power and see that 5 times 0 also equals 0, so it becomes 7 to the 0. But really, when the whole parentheses is to the 0th power, I can jump right to it being equal to mathematically 1. In problem 4, we have a subtraction symbol between the two terms. So really, since they have the same base x to the same exponent 3, we can just combine the like terms. 5 of them here minus 3 of them here leaves me with 2x cubed. In problem 5, we're going to be using the exponent rule for division that says we take power on top minus power on bottom and leave the same base. So we're going to leave the base b here. Power on top is 8 minus power on bottom is 3. That's how I wind up with b to the 5th. 8 minus 3 gives me 5. The 6th problem is like the first one. We're going to have to add the two exponents when we multiply x to the 10th times x to the 4th. Same base, add the exponents, 10 plus 4. That's how I wind up with x to the 14th. Problem 7, we've got power to a power. Power to a power, you multiply. So x to the 20 times 3. 20 times 3 is 60. My final answer is x to the 60th power. When we have anything taken to the negative first power, our 5th rule said we just do 1 over whatever that is. So this becomes 1 over the whole thing in parentheses, which was x to the 5th. For problem 9, we have 1, 2, 3 total x squared. So when we add 1x squared plus another x squared, we get 2 of them. Plus another x squared, we get 3 total x squareds. Again, we could add these because they're like terms. They all have the same variable x, all taken to the same power, the power of 2. Problem 10 asked me to do a to the 15th divided by a to the 6th. We're going to use our rule, power on top minus power on bottom. So it's going to become a to the 15th minus 6. That gives me a to the power of 9.